Our interest in this MiningImpact project is to study the behavior of the sediment plume that will be created by mining. The sediment plume is created when, by the use of mining equipment on the seabed. To imagine the effect of this plume, we have first to see what are the normal conditions here in the deep sea. We're in constant darkness, but if we were to have light, we could see meters or maybe much farther through this clear water. Now, when this large vehicle is going over the seabed and stirring up sediment, you will see nothing because the water will be very turbid, loaded with sediment particles. And then by the currents, at some time, this cloud of stirred up sediment will move away and move to outside the area where the vehicle is working. The sediment plume will have at least two physical direct impacts on the ecosystem. One is in the direct vicinity of the mining vehicle. There will be a heavy fallout of sediment from this plume. So fast deposition of sediment that was stirred up and settles again. And animals near the mining operation will simply get buried under centimeters, maybe more of sediment. Then farther away, there's still this cloud of turbid water that is gradually spreading out by currents. And particle concentrations are much higher than what these animals that live there are adapted to. And many of these fauna are filter feeders, so they collect their food by filtering food particles from the water. Now when we load a lot of sediment in this water, that will disturb the feeding of these animals. Because the sediment, it has no nutritional value and it dilutes the food particles. And these sediment particles may clog the filtering apparatus of these filter feeders. So at some point they will stop filtering and can't collect their food anymore. The questions about the plume, which we try to address in MiningImpact, is how far this plume will actually spread and what kind of concentrations can be found at certain distances from the mining operation. And so far the information we have is derived from numerical modeling. These are based on known current speeds and directions in the area, on particle size distributions, how large are the particles, and on known sinking speeds of these particles. What these models do not include or do not take into account is that the particle distribution in the plume may change. So particles may cling together, forming larger particles that possibly sink faster than predicted in this model. So this project now and this cruise offers a nice opportunity to actually look at this plume in reality.
We set up a plume array around where we wanted to do some dredging experiments. We did it on both sides, so if the currents would go one way or the other, we would still get a nice signal. So what we did was we deployed in total 14 small platforms by the RV. And we distributed them in 2 parallel lines on both sides of the dash track and then every time 100 meters further away. So we get a nice coverage of the area as well. The sensors we use are mainly optical backscatter sensors and ADCPs. The optical backscatter sensors, they emit a light wave and they see how much is reflected back. And that's a measure of the amount of particles that are in the water. And the ADCPs, they measure the current's direction and the current speeds by using the Doppler shift. But they also have a measure for how many particles are in the water by also how many acoustic waves are scattered back. Besides the small frames which are deployed by the RV, we have the BoBo lander, which is a 4-meter high yellow big tripod, which is released from the ship and then free falls down to the bottom. BoBo has a lot of sensors. It has 2 ADCPs, a couple of optical backscatter sensors, and hydrophone. In order to get BoBo back on the ship, we have to release it. So we go with a hydrophone into the water, and then we can send messages to BoBo basically, and then it releases the waves which are on the legs of BoBo, and then will just come floating up. Now, when all the sensors are back, we read all the data of all the sensors, and then we have to process them all, and that's something that takes quite some time. We get some preliminary results when we're on the ship because we can easily make some graphs, but to really look into what's happening, we have to process all of the data all together, and that's what we're going to do the next couple of months, basically.